Okay, so this is question 1. In the triangle ABC, AB is 20 and the angle B is 45. Given that AC is 16, find two possible values for the angle C, correct to one decimal place. I think you'd have to be crazy not to want to do some kind of diagram to start with, just to get a feel for what's going on. So here's a triangle, just a random triangle. The triangle ABC, how should we draw it? A, B, C. AB is 20, angle B is 45, AC is 16. Okay, so we're dealing with a triangle that we don't know to be right angled, so it's not Pythagoras theorem or straight colour stuff. But it is a triangle, and we have got two sides and an angle, and I think it's crying out for the sine rule, isn't it? Because we're wanting to find that angle there, which is opposite to a side that we know. We've got another angle opposite a side we know. So we're going to say that sine C over 20 is equal to sine 45 over 16. That's the sine rule that we're setting up. If we rearrange that, then sine C is 20 sine 45 over 16. Sine 45 is root 2 over 2. If we cancel that down, you end up with sine C as being 5 root 2 over 8, because we've got 5 over 4 times root 2 over 2, so 5 root 2 over 8. We're going to do inverse sine of that. Oh, I've not loaded up my calculator, hang on. So if we do inverse sine, yes, sorry. I'm in radians at the moment, so let's change so we're in degrees. So we're going to do inverse sine of 5 root 2 over 8. And the calculator is going to say 62.1 degrees. But notice the question did say find two possible values for angle C. We know that the sine graph does that. That's 180, that's 360. So there's the first value that we got at 62.1. So the second value is there. So that is 62.1 before 180. So our other value is going to be 180 minus 62.1. So the two possible values of this are 117.9 is the second one. 62.1 degrees and 117.9. Remember, the question did say for one decimal place. It asked for two values, okay, because there are two ways that we could draw that triangle. If you think about it, I've drawn it that way. I'm going to delete this in a moment. But if we carry on that line there, that line could be 16 there, couldn't it? And that could be the angle C. Can you see that we've got the two values? So one of these is acute and one is obtuse. And those are the two that we got. Right, let's get rid of all that. Okay, part B. Part 2, given instead that the area of the triangle is 75 root 2, find BC. Okay, we've got a little bit more that we need to work out with this. The area is 75 root 2. We know, don't we, that the area of a triangle is a half AB sine C. That's the formula that we've got for finding the area of a triangle. So it's the angle and two sides adjacent to it. So if we focus on that little bit of CB and AB, then we're told that the area, 75 root 2, is a half times 20 times BC times sine 45. So 75 root 2 is, well, sine 45, again we know this is root 2 over 2. So we've got 10 times root 2 over 2. So that's 5 root 2 times BC. If we divide both sides by root 2, that's 75 is 5 BC, and 75 is 15 lots of 5. So BC is 15 centimetres. That was quite straightforward. Second part, as long as you remembered your formula for the area of a triangle correctly. And that's maths.